Ok, anche quest'anno, diciamo, l'italiano è finito, mi hanno chiesto di parlare in inglese e così farò. Mi dispiace, ma ci risentiremo per le domande in italiano. So today I'm going to speak about network performance. Last year we have discussed a little bit about characterizing the HTTP traffic performance. And this year I want to give you an overview, an outlook of what we have done in the past few months and where we will be going next year with the integration of our results. So it is a very long time that people don't associate protocols with services just using ports or networks, simply because it is not really possible to do it today. Even the fact that port 80 used to be HTTP does not mean much. And on the other hand, HTTP does not mean much either, because on HTTP you can carry on Facebook, streaming data, and so on. So it becomes more and more important to understand the meaning of the protocols. And understanding the protocols, it has an important impact also on alarm generation. Because this morning we have seen that you can generate alerts based on traffic, you can analyze the HTTP header, but on the other hand, not all protocols have the same baseline, have the same thresholds for triggering alerts. And I agree with some of the people, the previous speakers that said that having dynamic thresholds is not a good idea. But on the other hand, we must have thresholds. And I believe that having thresholds, it is important to set them based on the type of protocol we are analyzing. So, therefore, it is important to characterize the protocol, not just to identify a protocol with a port, but once we have identified the protocol, then we can set up the thresholds, and then we can generate alerts based on the thresholds, based on the protocol itself. Another problem is the cloud. Many people look at the cloud like an opportunity, but on the other hand, the cloud is also an issue, because system administrators used to keep their data under their own protection. So they used to set up firewalls. They used to set up security barriers for preventing other people from accessing those data without, that was violating the policy, so without their willingness. So therefore, there are tools like, for instance, Google Docs or Microsoft Office, or even simple tools like Evernote that many people are using, especially on mobile devices, that are storing the data not on our private network, but somewhere else. So it means that having the firewall in place does not mean much these days. And on the other hand, it also means that your data are not under your protection. So we have heard today that, for instance, there have been a security violation on some of the important network services, and some services can be accessed without password, like in the past months, Dropbox had the same problem. So it means that your data is no longer protected as it used to be. But on the other hand, it also means that because people use the cloud, you must make sure that people are not just happy of accessing local services, but also are happy accessing remote services, such as those provided by the cloud services. So it means that we have to monitor not just our network, as we used to do, but also the internet connection that is bringing our data to the cloud. So, in addition to that, there is also the problem of virtual machines that have virtualized the world, but also added new constraints, because you know very well that as soon as the traffic leaves the virtual machine and goes into the network, you can start monitoring that. But if the traffic stays inside the virtual machine, or if there is intra-VM communication, this traffic is not actually seen on the network. So it means that whatever passive monitoring tools you can set in place, it will not be enough for understanding what is happening there. So this is another problem. And also traditional firewalls, those based, for instance, on port and IP addresses, are no longer able to distinguish, let's say, from good to bad HTTP. So because there are some services that are using HTTP in a good way, so for business, for instance, and there are other services that are using HTTP to violate your security. And at the same time, also HTTPS, that used to be considered a bonus, something good, is no longer the case if it is used for, let's say, malicious activities. In fact, people believe that the security, so the fact that traffic is encrypted, is actually a good value. I want to remind you that in all the critical systems, starting from submarines to the stock exchange, the traffic is not encrypted at all. It is mandatory not to encrypt the traffic, because it must be possible to analyze the traffic. So the fact that you have encrypted traffic, it means that you cannot analyze that connection, but it does not mean that this connection cannot be used for malicious purposes. So it is also important to go and analyze that connection to see what is happening there, whether we are connecting to our bank or whether this connection it is used for setting up by a user a remote VPN with a server that we would like not to do. So remote pings or periodic pings are no longer enough because we have this changed infrastructure. So in other words, we have to make sure that local services are in good state. Remote access to the internet is also done with acceptable performance. The cloud is available. So therefore, we have to passively track the traffic. Somebody this morning said that you cannot ping Google for the service. I don't think we have to ping Google. Google is by definition providing you a good service. So the point is, how do we reach Google? So is the way we reach Google satisfactory for our users or not? So we don't have to monitor Google, but we have to monitor ourselves using Google. So this is the point I want to make. So there are network key performance indicators, usually they are called KPIs, that are used for defining the baseline of some protocols. They're very well used for voice. So for instance, if you look at voice over IP, you know very well that there are certain parameters that you have to monitor. For instance, network latency, 250 milliseconds or 150 in case of G114, are the baseline. So there is no discussion here. It's not a discussion of setting up to 250 or 300 or 100. The standard says that, mandates that, and you have to set up that threshold. But unfortunately, there are very few thresholds like this, because most of the protocols don't have such a threshold defined by a standard body or by the guys that have defined the protocol itself. So therefore, it is necessary for us to figure out what are the thresholds we need to use. And in order to do that, we needed the packet inspection. So it means the ability of going beyond simple packet header analysis and go directly inside the packet payload. So actually in the data that the people are moving on the network. Not because we want to spy them, but because we want to look at the initial bytes of the connection to figure out what kind of connection these people are doing. So I want to know whether people are doing Facebook, or I want to know whether people are using HTTP for doing remote banking and so on. Deep packet inspection, unfortunately, is very costly. We had some experience with Würth Phoenix, and we have realized that this is very, very costly activity. I don't want to make you names or give you numbers, but I can tell you that we have realized that, unfortunately, this market is not mature, because most of the time, we believe this software was used in specific environments. So having them used, especially in kind of the open source, without an NDA, it is pretty unusual. But we wanted to be free to use the software and to deploy, to give it to people. So we decided that it was really time to develop something ourselves. So this is for going back to the previous question. So we have done something because we have seen a need, and the need was not filled by any company. Also, Linux with the level 7 filter, started to do something interesting in this respect, but was not fast enough. It was not flexible enough. So therefore, we decided to go our own way. So last year, I started to develop NDPI. That is basically an extension of an existing project called OpenDPI. That by the time we started working at that, it was pulled off the internet. So we started with that, and we had some extension coded in there. So at the moment, you can see there are over 140 protocols. So we are able to characterize most protocols that are important to people, and also those that are important to, I believe, also most of you, starting from Skype to messaging. So we can detect, for instance, Viber, WhatsApp, Citrix Online, and so on. So we can tell you exactly that this connection is Citrix. So we know exactly that if we want to set up a threshold on Citrix, This is the right type of connection. So we don't have to set up thresholds in a general way, but we can go directly into a special flow and say, this is what we want to achieve. And the result is basically this. This is an ntop screenshot. And as you can see on ntop, it is now possible, for instance, to create this type of pie charts. And when you see YouTube, it really means YouTube. So it means that we are aware, 100% sure, that this is the YouTube traffic. So we are not really using any kind of, I guess, I suppose. So if this is like this, it is like this for sure, 100%. And this is the important point I want to make. Without any kind of 100% certainness, we cannot really be able to generate alerts the right way. So we have seen that in the previous presentation that last year we started to do some kind of network delay analysis. We used the initial true shaking. People were happy, the initial feedback was good. But on the other hand, there are people that said that what if we have a long-standing connection? What if we want to continuously monitor the traffic? So we have extended that way the monitoring technique so that these days it is possible to have a long-standing connection, the ability to monitor the connection over time. So it means that we are continuously generating the network delay in each direction towards the client, towards the server, so that I can give you an update over time. So it means you can create those nice graphs that scroll dynamically. And adding NDPI support to the probe, I can tell you that this connection has this latency, and it is, for instance, Evernote. So I know exactly that it is because you are going to the internet, you're going to the cloud for downloading your favorite documents. So mProbe, as you know, has some generic key performance indicators. And those that for instance, we have seen in the previous presentation. So something like application delay, partitioning client and server. We have, for instance, indicators about packet retransmission. That means that there is something bad on your network because you are leaking packets. And the fact that you are leaking packets, it means that there is some kind of loss in the network. So, and because we can tell you whether it's on one side or on the other side, you know whether the connection is towards the internet or towards your LAN. So you know where to find the problem, or at least to search for it. Another point we want to make is about the packets out of orders. Packets should not be out of order. Whenever a packet is out of order, it means that there is some kind of congestion. So every packet is trying to enter the same tunnel, the same interface at the same time, but because this is not possible, the network device is trying to figure out which one to serve first. And usually small packets are served first. So if you see packets out of order, it means you have congestion. So it means that there is one point in your network where the tunnel, the link is so narrow so that not everyone can flow through. So it means that you have a problem in your network. So this is also a good source of indicator. Another generic KPI is TCP window change. The window is a kind of indicator of the trust that one of the peers has on the network connection. So when the window increases, or based on the protocol, for instance, SSH, you want to have a small window because you want to make sure that everything is happening as it should. You're fine. But if you see that the window decreases, so it means that the trust is kind of lost. So it means that there is a problem with your network, at least that the network is not behaving as it used to be before. So you have to find that. So having this KPI, you can create a baseline, okay, of the network healthiness. So you know exactly whether you are in good shape or in bad shape. And because we do that based on the network, we also feel how the network perceives the connection itself, the service you are providing them. And like I said before, as most of the time Google, those cloud services are doing the job, they can point the fingers at you. So if you know exactly that they're happy because the network is doing the job, basically you have no problem. So this is the statement. Another interesting point that we want to make here is that whenever you have an HTTP connection, for instance, you see that there are many actions involved. So there is DNS, there is the HTTP processing itself, and there is, for instance, the Oracle query. And because when everything goes well, okay, there are no needs to figure out whether a certain component is misbehaving. But in case of issues here, I want to exactly know whether it was Oracle default, or was the HTTP server or the balancer default, or whether the DNS was not responding fast enough. So we added some extension to the probe so that we can give you an idea of all those protocols and give you the query that a certain URL was performing, so that you can blame your programmers if they have used a query that was not optimal, or you can blame the HTTP server for not responding fast enough. So this is the idea. So the idea is that we want to move from general key performance indicator to protocol-specific performance indicator. And this is the point that we believe will differentiate us from the rest of the internet. I want to give you now an outlook of some of the metrics that we are supporting. Of course, I don't want to go through all of them. I just want to tell you that for DNS, we know exactly who's querying who, and we know how long it takes, which servers are supporting our query, so are resolving the query. In case of HTTP, we have worked a little bit with Würth Phoenix, so we had, for instance, support for balancers, so we know exactly which balancer is offering to carry on your query. So we know, for instance, that in case of poor performance that happens from time to time, maybe we have to blame a certain balancer machine that is not performing very well, whereas the others are working well. And as you can see, for instance, this is a Facebook connection. It is now possible to associate a user, so a human, with a connection and with the activity. So we also have to raise some issues about privacy that it was no longer the case until the social network appeared. In case of Oracle, you see as an example that we can tell query by query the return code, the query that was performed, how long it took, who was performing the request, and what is the server that is responding to us. So we know exactly also in the case of database, we also support MySQL, this is just an example. We know exactly how to correlate all the events together based on the time and based on the IP. So therefore, we can reconstruct all of them in a tree-like fashion so that we can exactly pinpoint at what component is not doing the job properly. As of HTTPS, of course, we cannot decode HTTPS unless we have the certificate, and this is usually not the case. So we decided that we wanted to do something with that. So we wanted to decode the certificate, and based on the certificate decoding, we are now able to exactly identify a certain connection, because we want to know whether the HTTPS connection was used, for instance, for connecting to your web banking system or for doing something malicious. And this is very important for discriminating bad usage from good usage. For instance, there are these two connections. The first one is the Facebook login. So I know that somebody's just logged in on Facebook. The second one, somebody's probably going to the home banking system. And as you can see, unless you decode the initial bytes of the HTTPS connection, you cannot do this kind of association. And by the way, this is the technique that we have used, for instance, for discovering some of the protocols. So for instance, this is the technique that Viber, that is a popular messaging system we use, or for Twitter, for detecting encrypted Twitter traffic, so to know exactly that this was Twitter traffic. So what is next? At the moment, we have integrated the deep packet inspection with nprobe. Würth Phoenix will help you setting up the thresholds per protocol exactly the way it should be done. So we know exactly that this is Facebook. Probably there is no threshold. We know that this is home banking. It has to be served in a certain way. This is voice over IP. It has to be served in the other way. But we said to ourselves that sometimes, especially in small to mid-sized companies, it is important to move beyond simple IP and ports firewalls and go probably towards something that is now called application firewall. And because those application firewalls are very expensive, and most of the time they are not very performant unless you buy the top models based in hardware, we have decided to start adding layer 7 support, not just for detecting the protocol, but also for implementing a passive bridge. So on the other hand, this tool that was created just for testing NDPI, while we developed some new decoders, for instance, for Skype, because the best test is that you put NDPI in the middle, you turn on Skype, if your Skype does not connect to the internet, you are happy. So it means that your Skype packet dropping is working. So we started to imagine that it was time for open source to create a cheap alternative to what those costly application firewall are providing to high-end users. So this is something that I think we'll introduce pretty soon. So just to wrap up, today I spoke about key performance indicator. I told you that they are important, but on the other hand, if we don't characterize the traffic, we cannot use those performance indicator to set up thresholds. Thresholds don't have to be dynamic. Thresholds have to be static. At least this is my point of view. So it means that you must know exactly, based on your traffic, what is the service level you have to offer people. And this is possible to do only if we know exactly the protocol. I've told you today that it's possible to analyze specific protocols, such as HTTP, voice over IP, or SQL, Oracle in this case, and know exactly that the action that was performed in case of voice over IP, who was called who, in case of Oracle or MySQL, the query. And of course, this paves the way to the next version, next release of NetEye that is integrating this protocol support so that you can have a better product in the future, having the characterization of the traffic on your network. Thank you very much.
Grazie Luca Deri. Domande?
Salve. Quanto è invasiva una sonda M-Probe a livello di rete di performance?
A livello di performance diciamo che non è invasiva perché tipicamente non viene inserita a cavallo del traffico, cioè non la mettiamo in line, la mettiamo si dice offline, cioè gli facciamo arrivare i pacchetti tramite o delle span port o dei network tap, quindi non è invasiva, non rallenta. Decisamente se la vogliamo mettere a cavallo del nostro traffico perché vogliamo bloccare il traffico può diventare invasiva, ma questa è proprio l'idea, cioè di bloccare il traffico.
E proprio per questo, a livello di privacy, come viene gestita?
In che senso?
Nel senso che comunque vediamo IP protocollo, d'accordo, non c'è l'URL, però sappiamo che quell'IP ha effettuato una chiamata voice over IP, come è gestito a livello legale?
A livello legale non lo so, noi siamo quelli che abbiamo sviluppato il tool. Abbiamo visto che nel caso per esempio di infocamere questo qui era necessario per sapere se una certa insieme di utenti faceva un certo tipo di operazione.
La domanda era semplicemente perché siamo un provider, quindi la facevo da...
la domanda allora la dovete fare voi a voi stessi. Cioè, noi vi diamo l'IP e vi diciamo che quell'utente lì magari è andato su Facebook. Poi se abbiamo alcuni dei nostri clienti che usano queste informazioni per caratterizzare, per esempio, l'utilizzo delle 8 ore lavorative per sapere se c'è un'attività prevalente oppure no. Quindi questo noi facciamo lo strumento, poi sta un po' a voi.
Volevo dare una risposta sulla privacy. Noi in realtà in un centro elaborazione dati esistono decine e decine di modi di violare la privacy, questo non è che uno dei tanti che esistono già, semplicemente l'importante è che questi dati vengano utilizzati soltanto per fare l'analisi a fronte di eventuali problemi e che restino in casa. È il sistema più semplice, insomma. Autorizzare soltanto gli amministratori di sistema a verificare quello che succede e mai e poi mai fare uscire i dati dall'azienda.
Ma per i vari protocolli non open, stile HTTP, di cui esistono gli RFC, ma vedi Oracle o addirittura quelli cifrati come Skype, come siete arrivati a identificare i pacchetti o qual è il tipo di comunicazione? È stato fatto un reverse engineering a livello TCP/IP?
Allora, per Skype sì, abbiamo fatto quello. Skype, il supporto Skype è nato, fino alla domanda iniziale, in una maniera un po' particolare perché un fornitore di banda satellitare ci aveva chiesto di trovare una maniera di identificare il traffico Skype, perché tipicamente i pacchetti, piccoli o grandi, per loro occupano slot e li volevano bloccare. Quindi è nato lì da loro, avevano un bel insieme di utenti che potevamo usare, diciamo, come cavie, e quindi è stato fatto proprio facendo reverse engineering, perché ovviamente Skype non pubblica come fatto il protocollo, e soprattutto è un obiettivo mobile, cioè sono convinto che tra qualche settimana, tra qualche mese ci dovremo mettere mano. Per quanto riguarda Oracle, il protocollo Oracle è diviso in due parti. C'è Transparent Network Substrate che è disponibile, cioè sappiamo come è fatto, e poi c'è la parte interna di SQL. Per quella parte là, diciamo, ci hanno aiutato i nostri amici di Würth Phoenix con tante query buone, cattive, lunghe, corte, per capire dove andare a cercare all'interno del pacchetto queste cose qua. Quindi, diciamo, se la vogliamo chiamare reverse engineering, abbiamo fatto così, ma come tanti protocolli del resto, cioè il fatto che anche l'HTTP abbia in qualche maniera codificato da qualche parte come è fatto l'header, non è che ci aiuti più di tanto, ci aiuta per capire la base dell'HTTP, però sapere che quello è Facebook piuttosto che Google Mail, cioè, è sempre un lavoro che abbiamo noi da fare. Comunque non ho detto oggi che tutto questo codice, sia del probe che soprattutto di NDPI di questa libreria, è libero, cioè nel senso che lo potete utilizzare per farci le cose, e non solo quelle che abbiamo fatto noi, quindi potete anche vedere il codice e le tecniche che abbiamo usato.
Altre domande? Allora direi che è ora di una pausa caffè.
Grazie.
Ci vediamo fra mezz'ora alle 4:30.